Hello, chemistry students. This is Mr. Danahy. A quick lesson on organic chemistry, topic 11. For topic 11, you're going to use reference tables P, Q, and R from the New York State reference tables. The reference table P gives you the prefixes that belong in the front of any compound name. The pentagon, hexagon, heptagon, octagon, those are all geometric shapes that kind of make sense with some of these. And you count the number of carbons in a chain in a straight line and get the proper prefix. For instance, for the alkane family, which I'll talk about in a second, the alkane homologous series is all single bonds. If I have one carbon, the prefix is going to be meth. And the alkanes, because they're all single bonds, all end in ane. And so the compound name for CH4 is going to be methane. On the left, I have the structural formula showing the four bonds around carbon. Carbon always has four bonds around it. And a hydrogen at each end of those bonds, four hydrogens altogether. CH4 is methane. And then the next in the series of the alkane family is two carbons. Two carbons, prefix is going to be eth. Since it's all single bonds, ends in ane. So this is called ethane. Hydrogen at the end of each of these single bonds, C2H6, is ethane. Take a look at compound number 3. Give it a try. What's the prefix here? How many carbons? 1, 2, 3, 4, 5. 5 carbons. Prefix should be pent. This is all single bonds. So it's in the alkane family, ends in ane. This is pentane. C5 and H10. If you count up all the hydrogens. So again, I said we're going to use the reference tables P, Q, and R in that order. Reference table P gives you the prefix. I've shown you how to do that. And down below is reference table Q, which gives you the suffix ane, ene, or yne. For the alkanes, which is one homologous series, when you have all single bonds, as shown in this structural formula. And the first in that series, or second in that series, is C2H6, as shown here, ethane. And any alkane ends in ane, and that clues you in that it's all single bonds. If it's all single bonds, it has a couple extra hydrogens in there. So when you write the formula, it's going to match this general formula. Notice that at the bottom table tells you N equals the number of carbons, N for the subscript on the carbon, and then you take that number and you multiply it by 2, and you add 2 more for an alkane. It'll always have that same general formula, 2N plus 2 for the number of hydrogens. And for the alkenes, because you have a double bond now, one double bond makes an alkene, ends in ene. It's no longer ethane, it's ethene. You lost a couple of bonding sites for hydrogen, so you lost a couple of hydrogens here. So the general formula is N for carbon, and the hydrogens are going to be 2N. The alkynes, you lose a couple more hydrogens, so now the general formula for the number of hydrogens becomes 2N minus 2. Again, to recognize an alkyne, YNE ending, you have to have a triple bond, and that's an alkyne, and this is ethyne. Going down the reference table, R. We'll come to this later, but just to let you know, when you have something special other than hydrogen, we use this reference table about functional groups. If you add in a halogen, group 17, if you recall from the reference tables, is a halogen. If you have a halogen, it's got fluorine, chlorine, or bromine, or something like that from group 17. That makes a hydrocarbon now a halocarbon. In order to do that, you add in what's called a halide functional group, fluorine, chlorine, or iodine, which is covalently bonded to the hydrocarbon. An alcohol functional group is the OH group. An ether has just an oxygen in the middle of the carbon stem. That's called an oxygen bridge. Ether, remember, oxygen bridge. Between the carbon chain, you've got an oxygen bonded to a carbon on each side. The R here stands for radical or wild card or the rest of the carbon chain. And you got one R on one side and R prime on the other side for an oxygen bridge in the middle. So that's reference table R. We'll come back to that later in more detail, but use the reference tables in order. Reference tables P, Q, and R. Have fun with it. It's really a lot of good information, and it fits. Just look for the pattern recognition and work through a few problems, and you'll get it. See you later, chemistry students.